So let's look at some examples. I've taken the liberty to get my graphing calculator out for these examples and graph the function and take a picture of it. What I did for this picture of the graph is, since my graph that was provided had an x-axis from -5 to 3, I set my window to go from -5 to 3, and for the y-axis I set my window to go from -6 to 4, so that I would get a picture here that looks similar to what I'm about to graph. And then I went to the table in my calculator, and you should know how to do that by now, in order to get some ordered pairs that I can use to kind of sketch on this graph to see what it looks like. I do want to point out that this, when you graph it in your calculator, the asymptote will not show up. That is something that you're going to have to graph yourself. I also want to note that sometimes these functions get so close to like the x-axis, but that it looks like the function disappears, but in reality, it keeps going to the left forever. It's just hugging so close to that x-axis that it looks like it's on it. But in reality, it's always going to be approaching that asymptote forever to the left. So it's gonna be so close that we can't tell sometimes, but that's okay. It's still happening. Before we jump to graphing this over here, I want to look at the function itself and talk about any transformations. The only transformation that I see is this negative sign at the very beginning. That negative sign at the very beginning means that there's going to be a reflection across the asymptote, which we're going to, at this point, call a reflect across the x-axis. The base of the exponent does not count as any kind of transformation. There is no plus or minus or negative in the exponent, no plus or minus at the end. So this is the only transformation. Now, instead of stating 3 points on the graph, I'm going to use these points from my calculator because I get more than 3 points there. And to graph them, to some degree, I kind of just have to estimate that -0.0016 is super close to the x-axis. For -3, -0.008, I'm also super close. Still super close for an x value of -2. Once I start to get far enough, like 0, -1, I'll start pulling away from that x-axis, and it'll increase very quickly. So 1, -5 is all I'm going to be able to fit. I can't do 2, -25 on the graph provided. Now, remember that one of your jobs is to sketch the asymptote. So that asymptote is going to be at 0 or y equals 0, which is the x-axis. So I've got to sketch that with a dashed or dotted line. My actual function is going to be a solid line. I'm going to try to sketch it to the best of my ability to kind of go through these points and curve in an appropriate way. I don't want it to cross my asymptote, so to kind of be careful not to cross the asymptote so that it looks good. Now, domain should be a simple thing for you to identify. The domain is all real numbers, always. But the range is going to be impacted by the asymptote. And since there was a negative at the beginning, this range is going to start at -infinity. In other words, we have y values forever down this function, all the way towards -infinity. And as we come up from those -infinity towards the asymptote, we stop getting y values at the asymptote. There's no function above the asymptote. So that's going to go from -infinity to 0. We've already stated that the asymptote is y equals 0. Now, is this function increasing or decreasing? Well, you start on the left and you start going down, and down is decreasing. So we're going to circle decreasing. And I'd like for you to know that that interval of decrease is -infinity to +infinity, just like the domain. In this case, there is no x-intercept. There is a y-intercept, and I don't have to find it algebraically because I can see it on the graph. It is 0, -1. If it were not on the graph and I couldn't find it easily, what I might do is I might plug in 0 for x and then solve for y, which would just mean putting it in my calculator. For end behavior, let's start on the left. X approaching -infinity means as I go left on this function, so left. Now, this is not going up forever towards +infinity. It's approaching something else. It's approaching the asymptote. So we're going to say that the function is approaching the asymptote, which is 0. On the right side, though, as x goes to the right towards positive infinity, our y values, our range, go down forever, and this time they do go down forever towards negative infinity. So if you've played with behavior before with previous functions in this class, this might seem kind of familiar to you, but what may be new is that we are approaching an asymptote on one side of the end of this function. We don't know which end is approaching the asymptote until we graph it. But we have to think left is approaching 0, is approaching the asymptote of y equals 0. The right side is approaching negative infinity because it's going down forever. In our second example, let's think about transformations here. The only transformation that I see is the +3. It's at the end of the function, so that should shift this function up 3 units. Instead of stating 3 points on the graph, we got a whole bunch of them here. So let's get those on the graph. -2, 7, I can put on the graph right here. -1, 5, I can put right here. 0, 4 is an easy one to graph. After that, I start having to estimate about where things are. 3.5, 3.25, 3.125, and I'm getting closer and closer. I'm starting to approach an asymptote. That asymptote, because of this shift up 3, is at y equals 3. So let's go ahead and use a different color and get that asymptote as a dashed or dotted line at y equals 3. When we're sketching our function, we want it to, approach that asymptote, but we want to be careful not to cross it. So we'll just very gingerly, very carefully sketch that so that it's doing the right thing. So we see this function right here. Domain of the function, all real numbers. For the range, since there was not a negative at the beginning, every part of the function is above the asymptote. So we start at the asymptote of 3 and go forever up. Y values would be everything from -3 up to positive infinity. This function from left to right, if I'm kind of walking, I'm going downhill. Downhill is decreasing, and it's decreasing from negative infinity to positive infinity. And otherwise, it's decreasing forever. Again, the function, because the asymptote is up here, it never crosses the x-axis, so there's no x-intercept. There is a y-intercept, and again, I can just look at the graph or the table to see that it crosses at 0, 4. For end behavior, as I follow my function to the left, left, I'm going up, 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 up forever towards infinity. As I follow my function to the right, right, I'm not going down towards negative infinity. Instead, I'm getting closer and closer and closer to an asymptote at y equals, f of x is the same thing as y, right? As y goes to 3. So as x approaches positive infinity, y gets closer and closer to the asymptote at 3. All right, just a few more examples. Thanks for sticking with me. Change the color just for different color on the graph here. Transformations. I notice that there is a +1 in the exponent. Remember that those are shift left or right, and since it's the opposite of what we see, we're going to say shift left 1. For the 3 points, I'm not going to recopy them down. They're all up here in this table. I'm actually going to put as many of those on here as I can. So -5, comma, real close to the x-axis. -4, still real close. -3, 0.25, about a quarter of the way to 1. -2, 0.5 is halfway to 1. -1, 1, 0, 2, 1, 4, and it looks like I'm going to be off of this graph. Now my asymptote, I did not shift up or down. Since there's no shift up or down, it stays at y equals 0. And you can see this on the graph here that y equals 0 is what this function appears to be approaching when we start connecting the dots, on the left at least. So we go left to right, connect the dots, try to sketch it as best we can. Doesn't have to be perfect, but it should look good. Okay. Domain, I hope that you get these domain questions on these functions all the time because it's all real numbers. The range, on the other hand, is limited by this asymptote. It's always above the asymptote. The asymptote is at 0, so we're going to say from 0 to infinity. This function is increasing left to right forever, so I'd circle increasing and say forever is negative infinity to positive infinity. There is again no x-intercept, and I'm kind of sad that there's not one because I'd like for you to see one, but there is not one. There's a y-intercept. We know exactly what it is. It's 0, 2 from the table or from the graph. In behavior, as I go to the left on this function, as I travel left, I get closer and closer to the asymptote of 0. As I travel to the right on this function forever and ever, I get closer and closer to positive infinity. It goes up forever. Last example today. We want to look at the transformations, characteristics, and graph of this function, -3 to the x plus 2 minus 2. I see 3 transformations. I see negative at the beginning. I see +1 in the exponent. And I see -2 at the very end. So I see 3 different transformations that I've got to catalog. The negative at the very beginning is going to reflect across the x-axis. The +1 in the exponent is going to be a shift to the left 1. And the -2 at the end is going to be a shift down 2. So I've got to represent all of those characteristics. Now again, my 3 points, I've got more than 3 up here. I'm just going to use those. -5, -2 point, something really close to -2. -4, something really close. We're still really close. Still kind of close, about a third of the way down. -1, -3. 0, -5. And I can't graph -11 for 1, -11. So as I'm graphing this function and connecting the dots, we're just going to show that it's going this way. Our asymptote did shift down 2 from 0, so it would be y equals -2. Please remember that your asymptote needs to be y equals. You're describing this line, so you can't just put the number -2 because the line could be like -2 could represent a vertical line or a horizontal line. We want to show that it's a horizontal line by saying y equals -2. All right, domain is all real numbers, but the range is going to be below the asymptote. So we'll start at the bottom of the graph, going up from -infinity to the asymptote. This function is always going downhill or decreasing from -infinity to positive infinity. There is, again, no x-intercept. That happens a lot of times with these functions, so don't worry that there's not one, but you will see some in practice, and if you have questions about those, please feel free to ask. We do know exactly where it crosses the y-axis at 0, -5, so we can put that point on here. For in behavior, as I go left forever, I approach. As I go towards -infinity, as my x values go towards -infinity, my y values go towards -2. As my x values go towards positive infinity, my y values go towards -infinity. Well, folks, that is it for today. So we've fit a lot of stuff into this video. They are little pieces that you should feel familiar with. I mean, we talked about these kinds of things with other functions before this year, and I believe that you also did in your 9th grade year. So as you're practicing, if you run into something that you don't recognize from your notes, feel free to ask me about it. But I think that you're going to be real successful with this.